Wherever you are, you can join us as we lift up our voice and bless the King of Glory. Maybe I will be a true suffers and a kind of your boy. Sense of fantasy or GIE. Be anyone in the same.
Alright, welcome back to our last video on how to draw graphs of quadratic equation. Okay, so in our previous lesson we learned how to draw the graph from the scratch, and then we came up with this graph. Okay, and I promised that in our very last video we are going to look at new sets of questions and how to approach it. Okay, now let's look at this specific question given to you on this graph. Now they are saying that we should use your graph to find a solution set of this and that, and then this and that. You realize from this question that the very first equation is dealing with what? The actual equation of what? The curve. You can see x squared minus x minus 2. Right? And then the next equation is just equation of what? A line. Right? So normally it's the equation of a curve and then the equation of what? The line that we use to find the solution set. Okay. Now if this is given to you, it's very simple. This one is a straight graph work. Okay. Now they want you to find a solution set between this and that. Now what you need to do, because everything we are doing is graphical, so this is already represented on the graph. That is the curve we plotted. So what next is what? How to plot this one on the graph. Now, equations like this are still equation of the line, but just that this specific line is actually an equation of the what? A line is an equation of a line that is straight horizontal. Okay. If you have equation of the line y is equal to a, it goes like this. Straight horizontal line at that point where a. Okay, and then if you have equation of the line x is equal to a, it's a straight vertical line. Please take note. Don't rather say x is horizontal, so x should be like this and y should know. If you are dealing with what y is equal to a, then it should be a vertical division, a horizontal line, and then x is equal to a should be a vertical division, which is what? A vertical line. Okay. Very good. So, with that known, then it means that if this is already plotted for us, then y is equal to 3 is what we need to represent on the graph. So we'll come to the graph and read on the y-axis 3. You see, y3 here. So at that point, 3, we draw a straight what? Horizontal line. Okay, we draw a straight horizontal line. So what we need to do is to draw a straight horizontal line like this. Straight horizontal line. Very well. So we draw this straight horizontal line. Then we realize that this line is going to touch the curve at this point, and then it's also going to touch the curve at this point. Yeah. So it's touching the curve at these 2 points. So all we need to know is we can just get what? The x value of this point here, and then we get what? The y value of that point. So we know the y value here is 3. Are you okay? Then the x value of this point as well, and then the y value. Okay. So after you plot your line, wherever it touches the curve, trace it to the x, then to the y, to the x, and then to the y. Right. If they are asking you for roots, then that one is only x and x. But if it's true set or solution set, then we need both the x value and then the y value, the x value and then the y value of the points. I believe it's fine. So with this one graphically, then the solution set or the truth set of this specific, and this one is what? X and y are such that, right, x is equal to, you see, x is what? You just read the value of x over here. So if this is -1, then this is minus 1.7. You can read it, okay? Minus 1.7. So x is minus 1.7, whilst at that place y is equal to 3. That one we know already. That when you place the value of y, you get 3, okay? And also, x is equal to, then you come to this side as well. You pick the readings over here. And then the reading here is what? 2.9. So when x is also what? 2.9, y is equally 3. Like that. Okay. So then the solution set goes this way. Okay. So this is much clearer and then much simpler. Okay. Now with the same idea you had for this, it's the exact same for the II as well. Just that the plot of y is equal to a is simple. That one we all know is a straight horizontal line. But when it comes to a linear function, then you remember how we do the linear. Okay? How to represent the linear one. So we've been able to finish with the first one. So let me take it off the graph. Okay? Let me take it off the graph. Very well. Now let's plot our new set here. Okay. So here, now we are looking for the solution sets of this and that. Now, before you draw this point here, I want you to look at something very simple. How you can easily draw this. First of all, you find y-intercept. Okay? You find y-intercept. Okay? So this is for I. We are dealing with II. So you first of all find y-intercept. And what is y-intercept? At y-intercept, x is equal to what? 0. Okay? So first of all, set x to 0 over here. That means that y is equal to 2 times what? 0 plus 2. So y is equal to 2. Are you seeing it? So one of the points is that at what? X-intercept, at y-intercept, x is what? 0 and then y is 2. So one of the points is there. Because you always need 2 points in order to plot a line. Okay? Then when you finish doing the y-intercept, come and do x-intercept. Okay? Do x-intercept. And at x-intercept, y is equal to what? 0. Okay? As x-intercept, y is equal to 0. So here, we do our y, we set y to 0 over here. So 0 is equal to 2 times x minus 2. So 2 plus 2. So 2x is equal to what? Negative 2. Hence my x is what? Minus 1. So at this point as well, we have another point called when x is minus 1, y is what? 0. Okay. So now we have these 2 points, 0 and 2, minus 1 and 0. When we get those 2 points, we can easily plot the line y is equal to 2x. Very, very simple. Okay. So now we have x is 0, y is 2. So x is 0, y is 2. So x is 0, y is 2. So we have first one here. And then minus 1 and 0. So when x is minus 1, this is 0. So here, at this point here. You get it? Aha. So now that you've located 2 points, then you can only just draw the line to pass through the 2 points. Okay? Draw a straight line to pass through the 2 points, and it must touch what? The curve. Okay? So you draw your 2 points. So this is the line we are referring to as well. Y is equal to 2x plus 2. This is the line. Okay? So that's the line y is equal to 2x plus 2. Then you quickly mark where it's touching the curve. And then where this is also touching the curve. Just like we did for the previous one. Then you read the values. Okay? You read the 2 values where it's touching the curve. So just like this. This one too, we have to read the value for that. So then the two sets of the II will be this. When we read the value here, x is going to be minus 1 but y is 0. Can you see that? where it's intersecting with this curve here. X is -1, y is 0. Very simple. So this is what? My x is equal to what? -1. Y at that place is what? 0. Then when x is equal to, you go to the second point, then you trace it to the x-axis, and that's 3.5. Can you see? So when x is 3.5, y is equal to, then you trace the y here as well, which is what? 6.8. So when x is 3.5, y is equal to what? 6.8. So this is also what? The solution set or the truth set of what? The second one. So these are the two things I wanted to introduce you to, right? To find the truth sets of what? This one, maybe the curve you have drawn and then a line. So you first of all plot the line, and wherever the line touches the curve, you trace to get the x value and the y value, get the x value and the y value of the other side. And that's the truth set. Nothing more, nothing less. Okay. So before I conclude this short video, I want to also introduce you to something. Imagine they said that you should use your graph. Use your graph to find the true set of this. Okay? Or the roots of this particular equation. So use your graph to find the root set of what? This particular equation here. This one they did say someone and this. But when you come here, you could realize that this equation is different from what? Our curve. And this is also what? A quadratic equation. So the question is, how then do I find the roots of what? This quadratic equation when I know a different one? Okay, so this is how we do it. Let me remove the line from this. Okay, so we are done with this line here. So here, they're asking us to find the roots of what? This equation using our graph. What you need to do is that, you see the graph you've drawn. The equation of that graph is what? Y is equal to x squared minus x minus 2. That's the equation. Bring this one below it. So you are going to have y. Okay? You are going to have y is equal to, normally they will say this, x squared minus x is equal to 0. Yes, it's equal to 0 instead. So you should find the roots of this. So here you bring this under it, so it becomes 0 is equal to, then you arrange them under the way this is. Okay? So s squared, bring the s squared down. Minus s, bring the minus x down. And then this guy to bring him down. Here. Okay? So we do this. Then you are going to subtract this equation given to you from the main equation. Okay, subtract this equation given to you from the main equation. So if you do that subtraction, you are going to have y minus 0 is still y. Okay, y minus 0 is y. S squared minus s squared is 0. Then minus s minus minus plus. So that one will also be what? 0. Then this is minus 2 minus minus 6 is going to be positive 4. So at the end of the day, when you subtract, you are going to get a line, which is y is equal to what? 4. Okay? And then we just saw we plot y is equal to 3. So it's easy to plot y is equal to 4, right? So you quickly go to your curve, locate y is equal to 4, this place. Okay, so this place over here. Then you draw your straight horizontal line. Okay, you draw your straight horizontal line at this place, y is equal to 4. Okay, then just like we were doing the old tradition, wherever this line cuts the curve, you read the corresponding x values, and that is going to be the root of what? This equation given to you. So where this cuts, just read the x values. So we have -2, and then where this one cuts here, just read the x value. We have 3. So at the end of the day, the roots of what this equation, the roots of that equation that we were asked is going to be x is equal to what, -2 or 3. And this is true. If you like, punch this one on your calculator and find the roots and see whether it's not be -2 and then 3. Okay. So anytime you are given either to find the two sets of this curve and then a line, then that one we say you plot the line and then you get the x and y values. Or they can ask you to find a two set of somebody or the roots of someone who is like this equal to what, 0. The same thing, but it's different from the curve. Then now we tell you subtract, and then you get a resulting line. Plot the line, like we've told you, and where the line touches the curve, you trace it to what? To get your x values. Okay. So it has been wonderful having you on my lesson regarding drawing of quadratic functions or equations. I hope and look forward to enjoy many more classes with you. Okay, so please kindly plot this for me. Yes, so get to us if you have any challenge. Then we are coming together, sit down, and achieve something very good. Okay. Thank you very much. Hope to see you.